We begin this lesson talking about slope, and there are several different names for slope. You will see slope referred to as simply rate of change, but in your homework, you will see average rate of change or a constant rate of change. So they ask for the rate of change, the average rate of change, or the constant rate of change. That all means slope. And slope is just how steep these lines are. So if you think about stairs, you go to like a stadium and that slope is really, really high. I mean, your quads are just burning by the time you get to the top. Or sometimes you have a slope that's really kind of flat and it feels like you've gone up 100 steps and you haven't really gone that much higher, right? So slope is how steep of a line this is. So we have different formulas for slope, but they all mean the same thing, and they all come back to this form right here of delta y over delta x. And I wanted to specifically put that in this lesson because as you go into higher level math courses, this is something you need to be familiar with. Now, delta just means change in. So my change in y over my change in x, when I'm given ordered pairs, means you're going to subtract your y coordinates. So we'll do y2 minus y1 over our change in x, x2 minus x1. Now, when I am graphing or finding the slope from a graph, we will use rise over run. But these all refer to the exact same thing, right? If I have my point 1 to my point 2, which they call P and Q, they do the rise and run under. I always go above. So from the lowest point to the highest point, I want to know what is my rise. And you can see here that is your change in your y coordinates. So what is that rise over your run? What is that change in your x coordinate right there? Okay, so we have 3 different types of slope that we're going to go over in this lesson. Because we are focusing on functions here, we don't have any vertical lines. But if my line is going up as you move from left to right, this is an increasing slope. And increasing slopes have a positive slope. So then opposite, as you're going from left to right, if this line is going down, we now have a decreasing slope. And decreasing slopes always have a negative slope. And then lastly, if we have a horizontal line, that is considered our constant slope. And constant slopes have a slope of 0. Okay, so let's apply this in example 1. In example 1, it says find the slope / average rate of change, which we do know that means the exact same thing. Then determine whether the linear function is if the linear function is increasing, decreasing, or constant. So first one here, when I'm given a graph, we need to find some ordered pairs. Okay, so I have several different ordered pairs here. What I am looking for is where this line is crossing that grid line perfectly, right? Where it's in the center. So for example, I have one right here because it is crossing perfectly at 3, 3, right? As I go lower, so like, for example, this is not one, right? Because it's right in between 2 and 3 on my y. So that doesn't give me an ordered pair of a whole number. If I keep going here, that's in between 1 and 2. But right here, that's crossing perfectly on my grid. And then if we go up, this one is between 3 and 4. This one is between 4 and 5. Right here, we get another ordered pair. So I have 3 different ordered pairs here. Because I'm using a graph, I'm going to use my slope formula of rise over run. You can rise and run from any of these 3 points. So you can go from the bottom one to the middle, middle to top, or even bottom to top. Let's go ahead and go from the bottom to the top one real quick. If I go from this bottom one to this top one, I first need to calculate what is my rise. And it looks like we are going up 1, 2, 3, 4 units. So we have a rise of 4. And when we go up, that is positive. Then making that kind of triangle here from this spot here, how many units are we running? And we are going 1, 2, 3, 4, 5, 6. And because we are running to the left towards all of these negative numbers, my run is a -6. Now we can reduce this right here. I get my calculator. Hopefully you can do that by hand. We can say, what can we divide into 4 and 6? And that is 2. So 4 divided by 2 is 2, and -6 divided by 2 is -3. So we have a slope of 2 over -3. But in case you aren't good with fractions, in our calculator here, a fraction is just division, right? So if I do 4 divided by -6 and hit enter, I get my decimal. If we come over here to math, the very first thing is to change this into a fraction. And we get that -2 over 3. Okay, so if you need to use your calculator, use your math button, and then the very first one changes whatever decimal you have into a fraction. Now, I want to make note of several things here before we move on. It does not matter what point you go to and go from. So, for example, we went from the bottom to the top. So I rose 4, which was positive, and I ran to the left, which is -6. If you go in the opposite direction and you start at this point, if you use your rise here, now your rise is more of a sink, right? So now your rise is a -4. And now what's your run? Now your run is a +6, and you still get to 2 over, or -2 over 3, right? So it doesn't matter which direction you go, because now I'm going down, we still get that negative, and now we're going to the right, and that's positive. You also get the same answer if you go from one of these 2 points to the middle point. If I rise from this lower point to this middle point, my rise is now 1, 2, and my run is a -3, and I get straight to this one here. We go up 2, run a -3. Here we go down 2 over a +3, down 2 over a +3. That is why this is called consistent rate of change, because no matter what point you go from, you should get back to that exact same slope. That's what makes this a linear function. So hopefully that wasn't too confusing. Part B, I now have an ordered pair. So because I have an ordered pair, I'm going to use my version of the formula, which is y2 minus y1 over x2 minus x1. I think it's easiest to label your ordered pairs. If I have -1, -2, and 5, 3, this is my first point and my second point. So my first point is going to be x1, y1. Your ordered pairs are always in the form of x comma y, and because this is my first ordered pair, it's going to be with subscripts of 1. Then 5, 3 is still going to be x and y, but now because it's my second point, we're going to have subscripts of 2. So that's my x2, y2. So now that I have my formula, and now that I have my points all labeled, this is just straight substitution. We have m equals, m represents my slope, y2, which is labeled as 3, minus from the formula here, and then we're going to subtract y1. Well, y1 is a -2. So before we go down to the denominator, let's pause right here and make sure we understand why I have a double negative. That first subtraction comes from my formula, and then my y1 is also a -2. So first one from the formula, second one from the number I'm substituting in. Same thing happens down here. My x2 is 5, minus from that formula, and then what is your x1? Your x1 is a negative one. Okay, we're subtracting negative numbers. When you subtract a negative number, that's the same as addition. So 3 minus a negative 2 is the same as 3 plus 2. 5 minus a negative 1 is the same as 5 plus 1. So here, my slope is 5/6. Now, we forgot to do it on this one, so let's do it on this one. We'll come back to part A. We're also supposed to determine whether the linear function is increasing, decreasing, or constant. Well, let's actually start with this one here. Because I actually have a graph, I can say that it is decreasing because I can see my graph as I move from left to right, that line is going down. I can also tell because I have a slope that is negative. Any negative slope will have a decreasing slope. So here, without even having a visual representation, because I have a positive slope, this must mean that my slope here is increasing. Because positive slopes are increasing slopes. Okay, our last one here on part C. With this table, you have multiple different options. You can plot any of these ordered pairs or all 5, right? We have 5. We've got -2, 4, -1, 1, 0, -2, 1, -5, 2, -8. So you can plot them on a graph and then count the rise and count the run. You can pick 2 of the ordered pairs and use this formula right here. Or I'm going to use my delta y over delta x right here. My delta y, I'm looking for what is my change in y. How am I going from 4 to 1, from 1 to -2, from -2 to -5, and -5 to -8. All of these are being subtracted by 3. 4 minus 3 is 1. 1 minus 3 is -2. 2 minus 3 is -5. -5 minus 3 is -8. So my delta y is -3. Do the same thing over here to find your delta x. How am I going from -2 to -1? -1 to 0, 0 to 1, and 1 to 2. All of these are increasing by 1. So my delta x is a positive 1. You can say that your slope is -3/1, but more simplified would just be -3. And because we have a negative slope, that means that my slope here is decreasing.